Number of enclaves. You're given an m times n binary matrix grid where 0 represents a C cell and 1 represents a land cell. A move consists of walking from one land cell to another adjacent 4-directional land cell or walking off the boundary of the grid. Return the number of land cells in the grid for which we cannot walk off the boundary of the grid in any number of moves. So in this case it will be 3, because for this one I can walk off the boundary, and this one I can walk off the boundary, so it will be 0. Like a BFS, I'm guessing. So you go through each of the matrix elements, this one, this one, this one, this one, and then when I see a 1, I want to do a BFS from this, and if I can walk off the edge of the boundary, then I return true or something like that, and as well as the total number of ones that it is 4-directionally connected to. In this case, it will turn true because I can walk off the edge of this, and also it will return 1. Since I can walk off the edge of this, I don't count the number of adjacent ones. Then I eventually get up to this one, do a BFS, and I see that I cannot walk off the edge of the grid, so that means I should count the number of adjacent ones that I see, and that's 3, and add it to the total answer. But I make sure that I set everything I touch to 0, so that when I get down to here, this is 0, so I don't do it again, and then so on and so forth. Did I say BFS? I meant DFS, because DFS is a lot easier. How do we do this? What we can do is we could have an integer num adjacent starts at 0. Whenever I meet a 1, I do a DFS, and I increment num adjacent. Before I start doing the DFS, I want to set num adjacent to 0. And then I have a DFS as well, so DFS in. Now I should return a boolean, whether I can or can't walk off the edge of this. So I'll pass the grid in, vector of ints, and the grid, and also what cell I'm up to, so int I, int j. Okay, so this will do, something. How do I use the DFS? Well, I would have to set num adjacent to 0 before I do the DFS. So this will be in a loop, and the loop would be for int I is equal to 0, I less than grid dot size plus I, and for int j is equal to 0, j less than grid 0 dot size plus j. Set this to 0. I could have a continue statement. So if something, then continue, right? If the grid at I, j is equal to 0, then continue, because I don't need to consider it. Set num adjacent equal to 0, and then do a DFS on the grid at I, j. And this will turn true or false. If this would turn true if I can't walk off the edge, in which case I just want to continue as well. Otherwise, I want to keep track of an answer and do answer plus equals to num adjacent. Then return the answer. That's how I'd use it. What should the DFS be? Well, I want to consider all adjacent cells. So let's keep track of dx, which is a vector of 4, and let that be equal to 1, 0, 1, 0, minus 1. And something similar for the y. So this will be 1, this will be 0, and this will be, say, minus 1. So the first index is 1, 0. That means we go to the right. 0, 1 means we go to the top. We go upwards. Minus 1, 0 means we go left. 0 minus 1 means we go down. If the grid at I, j, well, actually, I want to check a base case here. If I is less than 0, or j is less than 0, or I is greater than grid.size, greater than or equal to grid.size, or j is greater than or equal to grid0.size, turn true. Otherwise, keep track of result. Result is equal to false. And then go through each of the corners. So int I is equal to 0, I less than 4 plus I. And then calculate the new coordinates. Maybe nj is equal to dx of I. Maybe we'll not call it I actually. Let's call it d for direction, and this would be ni, and j would be y. Although that this cell could be a 0 cell. If grid at ij is equal to 0, return false. I'm not walking off the edge because it's a 0 cell. Here I do a DFS on the corners, so it'll be DFS of grid, pass in ni and j, and then return result. But I have to bitwise or result n equals to this. So if any of these values can walk off the edge, then I return true at the end. Think that will work? Let me step through the logic here. So I'm here. I'm at 1. And I'm not out of bounds, so continue. Result is equal to false. Go through each top, right, bottom, and they would all return false. So I'm bitwise only was false and false. But when I get to the left side, it's out of bounds, so I return true. And then, so this result will turn true, this is return true. I don't add num adjacent to the answer. I need to increment num adjacent. So I need here, I need to go num adjacent plus plus. Then I get to this one here. It's not out of bounds, it's not a 0. I go through all of them return false other than this one, 1, in which case, when I'm at this one, I do a DFS again, looking for the adjacent cells, except that this will result in an infinite loop because I'm not setting these values as 0 as I go along. So let's make sure I do grid at I, j is equal to 0. So then when I'm at this one here, I check all 4 directions, which includes where I came from, but that's a 0, so that will return false. So that's okay. And then also check everywhere else. I'm not going off the edge. They return false. Get to this one. Yep, and that seems to work. Let's run that. A semicolon there. This should be I plus the difference in it and j plus the difference in the y. There we go. Let's submit that and see. Seems to work. What's the time complexity of this? Well, the DFS never revisits the same cell because we are setting each cell to 0 as if we touch it, which means we won't consider it again in the main loop. So it's O of n times m. Alright, thanks for watching. Like and subscribe. Keep eating the code, and I'll see you in the next video.